Good morning, everyone. We will start in a minute now. Other people will connect progressively. Just a rule, if you could please keep your micro turned off while we are presenting, and then we will open the floor to questions in the end of the webinar. So I'll let Stéphane the floor to introduce the webinar.
Okay, good morning and good afternoon, everybody. Thank you very much for taking part of this event. So this webinar aims to present the work carried out by CEDRE on the topic of chemical products and the risk in the event of a spill. Shut down your microphone, thank you very much. So as I said, we are working on chemicals product on their accidental release at sea and what is possible to do for the response. This topic is a part of a long-standing effort at CEDRE because it was initiated in the early 2000s. Today, more specifically, we will present the results from the Manifest project and its follow-up, Manifest Genus, two projects funded by the DG ECO and implemented by the same consortium that it's very important to underline. Perhaps we can go to the next. Exactly the same consortium. It means that we have 5 countries involved in this project, 9 partners. So both projects were led by CEDRE, and as partner we have HSE from UK, Airbins from Belgium, INTLS from France, Antecmar and CEDMAR from Spain, and the University of Lisboa, Polytechnic of Lisboa from Portugal. Given the time constraints, it's not possible for us today to cover all the results in only 1 hour. So today we will focus especially on experimental results. That means Laura will present you part of the work she has done here at CEDRE, experiment to demonstrate, to determine how chemicals can behave at sea. After, we will have few words from Ludovic Lepers from Airbins, and he will explain the modeling tool, what was done in the framework of these 2 projects. We have Paul Harold from HSE UK. He will say a few words concerning the safety of the people and also the responders. And finally, Laura will take again the floor in order to present the work performed by CEDMAR, the training box. What is important to keep in mind, or to precise, it's that all results are available online and are freely accessible. So I will just conclude by saying thanks a lot to the DG ECO, thanks a lot to the Europe for funding this project. Laura, it's your turn. Thanks a lot.
Okay, thank you, Stéphane. So no need to repeat this is how the presentation will be structured. So I will directly go to the project background and objective. And just a short reminders for those who connected later, just please keep in mind to keep your micro turned off while we are presenting. It will avoid any interference. Thank you very much. So as H&S spills are still a complex challenge in comparison to oil spills, for which response options are generally well known. We can use boom, skimmers, solvents, and so on. But for the case of H&S spills, this is not the same story, because there are actually more than 200 million tons of H&S that are transported per year at sea, and around 2,000 different type of substance traveling. So this is quite difficult to have information regarding their reactivity and behavior. Also, some can form some gas cloud, particularly volatile or gaseous HNS. There is also, when possible, when some response is planned, it is difficult to know the compatibility of response equipment. So this is a risk for responders and population in case of release near the shoreline. Of course, it can also have some environmental impact at longer term. So this is still a challenge for responders to manage such situation, and we still need some information, some data regarding those chemicals. So that's when the manifest and manifest genius come in, as Stéphane said. Just a short reminder of what was the first manifest project. So this project focused on a scenario involving the release of liquid HNS at sea surface that could potentially form a toxic gas cloud, even flammable or explosive. And the general objective was to develop operational decision support tools to improve the response by collecting experimental data to enhance our knowledge on their reactivity, but also to update some existing HNS database. Also to improve risk prediction by developing models on evaporation, fire, explosion. And finally, to perform the stop exercise and field trials to improve intervention protocol and to test some specific sensors. So this is what was developed during the Manifest first project. So this is the Manifest decision support tools. We have some specific databases, for instance, the Manifest Minor Knowledge Tool, which includes technical resource on marine research dealing with preparedness and response regarding HNS spills. We also have the HNS database that will be presented by Erbins just after. We also have some modeling app you will see after, the decision-making guidance on sheltering or evacuation, and also the common operational picture tools, which is a web-based platform that creates and manages a general picture of various layers of information during marine pollution events. So in 2024, we received a new grant to continue the work performed on manifests. And for this project, the general structure was almost the same as for the first one. The focus was on volatile HNS, including alternative fuels such as ammonia, methanol, LNG. And this time there were two incident scenarios: a surface leakage near the shoreline and underwater release from a pipeline. And so we also perform experimentation, also surveys, exercise, training materials. In fact, this time the priority was given to share all the tools that were developed during the first manifest project, and of course to update the existing decision support tools. So for the Manifest Genius, the leader was still set with 7 partners. It ended up last March, and the main objectives were to assess the behavior and impact of volatile and gaseous HNS in seawater, to provide information to assist stakeholders in preparing emergency plans and response protocols for sites with transport pipeline of anhydrous ammonia-based refrigeration systems, to improve information sharing among marine pollution responders, during an incident near the shorelines. This was to enhance coordination, efficient coordination of the land and sea response. And finally, to transfer knowledge and train stakeholders on the use of the decision-making tools developed in Manifest and Manifest Genius. So we will first start with the experimental tests that were performed to assess some risk related to those chemicals. So this is the work that was performed at CEDRE regarding evaporation and dissolution of such substances. To recap, we used 4 experimental tools and we studied 5 chemicals. So for the surface release scenario, we use our wind tunnel that was developed to assess the evaporation kinetics of chemicals, so either pure or released at the surface of seawater, as a function of wind speed. Then we use also our chemistry bench that enable us to assess and to study the competition between evaporation and dissolution. And for the underwater release, we use our experimental column to monitor the dissolution rate of some HNS, so methane here, during his transfer in the water column, so the rising into the water column. So this is just some more details regarding each tool and what key data we can collect. For the wind tunnel, what we do is to continuously monitoring the HNS mass loss over time. You can see on the right. Of course, we monitor also air and liquid temperature, and we can control wind speed. So it allows us to assess the evaporation rate for each wind speed. Then for the chemistry bench, the key data is that we can have the simultaneous concentration of the HNS, so both in seawater and in the air. We can also monitor temperature in both seawater and air, and so it gives us some sort of mass balance, and so we have insights into the interplay between evaporation and dissolution. So this is around 8-hour tests. And then for the underwater release scenario, what we do is to inject the gas at the bottom of the column, so it then using some optical device with a light shadowgraphic technique, it gives us some information regarding the area of particles or bubbles shadow. And so we have information regarding the rising speed, but also the gas bubble dissolution. So we have both columns. The only difference between CEC and C cube is that for C cube is an infinite rising of the chemical. So we have information regarding the rising speed and dissolution rate of a chemical in the event of a subsurface release from a wreck, for instance, and we can know if a chemical slick will form at water surface. So for this experiment, the main conclusion, for instance, for the wind tunnel, were that high wind speeds, of course, increase evaporation. So this raised the risk of toxic or flammable vapor clouds, and it can expose response personnel. So wind direction and speed are critical decision variables for setting exclusion zones. Here, what you see on below is just an image from our colleagues from ONERA. Thanks to their work, we were now able to improve our wind tunnel through a hyperspectral imaging system. Then regarding the chemistry bench, the evaporation is generally dominant and faster than dissolution. And for the experimental columns, high methane leak rates can saturate locally the surrounding water, allowing methane bubbles to reach the surface. And also, it was shown that methane has a size-dependent dissolution kinetics. That is to say that smaller bubbles dissolve faster than larger bubbles. And so assessing plumb size, leak rate, and leak depth is essential for defining safety zone. So you can find all the results available on deliverable. You can see here on the right, available on the project website. And just to inform you that other experimental tests were performed by our colleagues from EMT Minales on gas cloud characterization and detection. We did some underwater release of gaseous methane and ammonia in CEDRE outdoor testing pool, just to simulate a blowout and to assess its consequences regarding water elevation, surface currents, and also if we could observe some gas cloud. And this is what we observe. On the right, you can see after injection, we can observe some methane gas in the air with the hyperspectral camera from our colleague from ONERA. And also another test was the release of gaseous ammonia above water at the fire safety department in Brittany. So the objective here was to monitor variation in temperature, both in air and in the water. And you can see in the middle here, this is the cloud of ammonia. And in fact, it just caused some immediate condensation of humidity in the air. And also what was observed is this precipitate cloud in the water, which is some calcium magnesium precipitate. So all results are also available in this deliverable on the project website. And finally, how those data are used. This is in fact data that are used to calibrate risk prediction model, but also to update the HNS database. And so this makes me leave the floor to Ludovic that will present also the gas upwelling model based on the data we had regarding the testing column in CEDRE columns. So Ludovic, the floor is yours.
Thank you, Laura. So as Laura just said, you can go to the next slide. Yeah, so we need to know how the gases or the liquid of the chemical works in order to be able to respond accordingly to the threat. So you need to understand how dangerous is the chemical. Is it dangerous to human, to the environment? How far is it dangerous and for how much time? Thankfully, all the experimental work was already able to give us a lot of insight into it. But now what we developed too is a new decision support system. So that consists mainly of a database and a modeling app. The idea of this decision support system is to provide insight both for preparedness, but also in response. Next one. Yeah, so I will start by explaining you a little bit how to access the HNS database and what is this HNS database. So you can go to our manifest project website using this link or scanning the QR code after the presentation. So next one. And yes, you just have to click on the tools on the top and then you see all the tools that have been developed in the manifest project. No registration needed, just click there and then you will be able to access them. The first one I will talk about is the HNS database. So you just have to click on the top there. Next one. And this database is a fusion between the mystery source database from the REMPECT and the HNS-MS database. It has more than 600 HNS entries. It has been updated during the project with toxicity information about ecotoxicity, LC50, RAGL, etc. And it has also fire and explosion parameter about for many chemical. The very nice thing about this database is that it includes also experimental data at various temperature and or salinity, such as hydrosolubility, physicochemical parameter, but also evaporation rates that has been determined experimentally by CEDRE, as Laura just explained earlier. Yes, you can go to the next one. So now, how to use this database to gather information about chemical. Like for instance, imagine you have a place where you are carrying after, a chemical acrylonitrile, or maybe you have an accident with acrylonitrile. So you probably have no idea what this chemical how this chemical behave, what are its properties, and so on. So you just have to type the name on the search bar, and then you will have to click on one entry of the acrylonitrile, and you will get to the acrylonitrile datasheet. You can go to the next one. Yes, so you will get to a page like this one. At first glance, you see directly that acrylonitrile is toxic both for human, for the environment, and it's also flammable. So you know that it's a serious threat that needs to be taken care of. Another thing you can see quickly is that it's a dissolver that evaporates. So it's both important to be ready in the air and underwater. And you will be able also to access a lot more data if you scroll down on the page, like for instance the physico-chemical data. Next one. That you can see there, you see a lot of properties at this stage, and you see that you have a lot of blue line. All these blue line have been determined experimentally by CEDRE in the framework of the project. Next one. Now that you know how your chemical behave, you want to know what will happen with this chemical. So you just have to go back to the tools and you click on the modeling app registration. That's still on the same menu. And for the modeling app registration, everyone can ask an account, but you have to be from some maritime institution to have access to for safety reason, security reason. But just do an online request saying from which organization you are if you're interested to use our tool, and to say why you want to use our tool. You can go to the next one, where you see you will get to our dashboard, so fully on the web browser, and then you can start and see simulation that you run fully online. Next one. That you see you have a field to start a new simulation. You just have to fill a form that you need to fill with the accident data, the chemical properties that are directly taken from the database, and so on. The first model I will talk about is the explosion model. So imagine you have a chemical, a gas cloud, or the potentiality to have a gas cloud and to have an explosion. You are asking yourself what will be the impact of this gas cloud. So you fill the form and you start the simulation. Next slide. And you will get a result like this one, for instance, where you see directly that the largest area is where you have the impact. You see, you just have to move your mouse around the ellipses, and you see the impact expected in each ellipsis. For instance, the largest one, you expect to have glass breakage in this area, so risk of indirect injury for people. And the closer you go to center, of course, the most you expect to have a large impact to people and facilities. Our next model, you can go to the next slide, is Osirit model that has been improved a lot during the Manifest project. The idea of this model is a bit different, is that you have some release at sea, and from this release you want to know where the HNS will go, in which concentration, and also it predicts how the HNS will be. Will it be dissolved? Will it be evaporated? Will it be a mixture of both? That is the kind of information this model can give you. It uses real-time current, wind, and wave prediction in the North Sea and the English Channel. You can go to the next one. Here is an example of result for ammonia. You see in blue that you have a gas cloud that leaves toward the south, and you see in the water some color that is the concentration. That's a typical output that you can get out of this model. So it gives you some insight about both the water concentration, and the direction and the concentration in the air can also be provided. You can go to the next one. where you see also it can give you some insight if we expect more, in this case, ammonia to be dissolved or evaporated or at the surface. Here we say that the model predicts everything is evaporated, but a little bit stay dissolved in the water and continue to slowly evaporate with time. The last model I will talk about today is a model about, about gas rising in the water column. So imagine you have a chemical tanker containing gaseous chemical that sink toward the bottom, and then it has a hole, or you want to know what would happen if it has a hole, or you have a pipeline that has some rupture or could have some rupture, and you want to know what would happen in this case. And next one. In this case, we have this model. So you see that it predicts the rising of bubble through the water column. So it's work a little bit like it is shown in this animation. You see that you have in 3D gas that rise through the water column. And the thing is that maybe it will dissolve with the water, and that you will have some gas dissolve in the water column, and that can have serious impact on the environment and decrease the amount reaching the surface. That's where its output is useful. So next slide. That, for instance, it gives you some idea where the gas will dissolve. You see in this specific case as example, most of the dissolved gas will be near the seabed and not a lot near the atmosphere. So you probably don't expect a second release through time. And the last output it can produce in the next slide is the repartition. So here in this case, we see how long it takes for the gas to reach the surface, but also in how it will reach the surface. It will be more bubble, it will be volatilization or other processes, or it's still dissolved. This model is not available in the interface, but it can be downloaded in next slide. It can be downloaded on GitHub and installed on your local computer. If you have any question, I'm available at the end, but now I think we'll talk with Paul about the guidance of those potential gas clouds, for instance. Thank you.
Thank you, Ludovic and Paul. The floor is yours.
Thanks, Laura. Thanks, Ludovic. Good morning, everybody. My name is Paul Harold. I'm an environmental public health scientist. I work for the UK Health Security Agency. And our interest is in impacts on the wider community, with a focus on public health protection. So if we could have the next slide, please. So as is already mentioned, we're interested in the gaseous and volatile HNS that might be released in an incident. Basically because if they're flammable, explosive or toxic, they can quickly move away from the site of the incident and impact a wider area, which may impact local communities and areas of population, etc. So there's a potential for a rapid public health issue. Next slide, please. So what did we do? Well, initially we looked at the evidence around the public health impact of incidents and also the frequency and type of incidents that occurred with gases and volatile HNS. What we found was that incidents involving these substances were quite limited when you look at reports of serious and very serious incidents, only about 1 to 3% of the total. But a lot of them were occurring in ports near the shoreline, and so they could have potential for impact. And several of the incidents that were reported were shown to have quite significant public health impacts, such as chlorine leak in the port of Mumbai, another incident with vinyl chloride in the Manchester Ship Canal in the UK. So the risk is there. There's a major risk there. We also took the opportunity of surveying UK stakeholders involved in planning and response to incidents, not just maritime, but all incidents, and surveyed them around what their experience was like on this type of issue in the marine or port environment. And we found that the experience of incidents from this community is quite low. So there's limited experience, and there's no real specific procedures for maritime settings. So we will be applying land-based procedures where they could. Also, a lot of these stakeholders didn't have their own modelling or monitoring capabilities, would have to request this from other contractors, which obviously requires time. When you've got an incident involving gases and vapours, time is the essence, really. And the main gap that was identified by the survey is around training. A lot of the stakeholders were keen to have training on these sort of issues. Next slide, please. So what we did is we looked at taking this evidence and developing some guidance that could be used for decision making in the golden hour of an incident, i.e. the immediate phase when first responders are arriving at the scene. They don't have monitoring, they don't have modelling data. And also, but this would also be used as more of a training tool, but could also be used as a planning tool as well, so that different scenarios could be gained at locations to see what possible actions could be taken. So it's really a sort of step-by-step guide that we've developed, where although a lot of it is quite general information, it's really about looking at the considerations, the things you need to consider when you're developing your decision making during an incident around protecting the wider population. So if we could have the next slide, please. Why did we do it? It's pretty much standard response. There's only 3 ways you can respond to an incident with involving gases and vapours to protect the public. 1 is do nothing, 2 is shut your doors and windows, and 3 is run away. So that's nothing new. It's been done on land for many, many years. And shutting your doors and windows is the kind of default advice. But when you're looking at coastal and port environments, there are things you need to consider. Coastal environments often have a lot of deprivation, they have a lot of susceptible populations. Older populations tend to retire to the coast. Holiday season, there's lots of young children. These are susceptible populations, more likely to be impacted, their health impacted by exposure to these chemicals. A lot of dwellings in areas are temporary, such as campsites, etc. Infrastructure is limited, and internet connectivity, communication connectivity can also be limited. So awareness is very important in this sort of setting. Next slide, please. So really, in terms of the guidance we've developed, this is really for a sort of training tool. You start off with, is there a public health risk? That's box 1. You've had an incident, should something be done? So what you need to know, is there a hazard, is there a risk? And you use a source, pathway, receptor approach, and go through the checklist. Is the chemical hazardous? Is the chemical volatile? Could it migrate off-site? Are communities downwind? And it gives you an idea of what information you need to know, whether it's available. And you need to know the sort of things, what chemical is involved, if you can find that out. What sort of size of a leak or a release have you got? Is it large, medium, small? And there's, in the guidance, there's definitions for these things. Is there a pathway? What is the pathway? It's going to be atmospheric. Which way is the wind blowing? Is it raining? What time of day it is, which can impact the way things can develop. And then when you've got some idea of which way the cloud is likely to go, are there communities downwind of that? So with that information, you can then determine if there's a public health risk. Next slide, please. If you've broken any of those elements, or those elements don't apply, it's not toxic, there's no communities downwind, then the chances are there's no risk and no further action is required. If there is any of those elements involved, then there's likely to be a risk. Your first decision is, your default decision is shelter in place. And there's some things to consider when you're looking at shelter in place to see if that is going to be adequate. Yeah, I think there's another, yeah. So it's likely to be okay if you've got a small to medium spill. The cloud will pass fairly quickly. Sheltering will only give you so much protection. If you've got a very large spill or something that's going to be ongoing for a while, then you might have to consider evacuation. Also, if there's an explosion risk, you need to consider evacuation. And also looking at the types of structures, the types of people that are likely to be in those structures. For example, have you got care homes, hospitals, etc., which could limit ability to evacuate, and whether the chemical is highly toxic or not. And in terms of high toxicity, we've looked at the GASAMP process for establishing acute mammalian toxicity and applied that to current guidelines. Next slide, please. So when you've looked at those considerations, you may want to consider evacuation if evacuation is needed, and this has to be done very quickly, so this information needs to be available at the time. When you're looking at evacuation, if you've got an explosion risk, evacuation is very likely, because you don't want to be in a building when it's subject to an explosion. If you've got a large or very large spill, it might also require evacuation, or temporary structures, or a very highly toxic chemical. And if evacuation is the chosen option, then you need to know if it's feasible. Can you get people out in time? Can you do it safely? And is there sufficient resources locally? And also, will you be subjecting those people to unnecessary exposure if you do evacuate? So these are the things that need to be considered, and how we see this working is as a kind of operation during the training exercise. You would take each phase. You could also apply some of the modelling that the on-demand modelling that Ludovic mentioned earlier. Next slide, please. And this just illustrates the guidelines that we were using to develop whether chemicals are highly toxic. Like I say, we used a guideline based on the GASAMP principle, and then looked at the protective action criteria against that. And there are a few chemicals that we would consider, such as chlorine, where you really need to consider evacuation if you've got a large spill. Next slide, please. And then when you've considered these elements, then you make your decision either to shelter or evacuate, usually shelter, but in some cases evacuate. You then need to think about communicating this, how you're going to get people, make people aware of this in the environment that they're in, and obviously review information as it's received. Next slide, please. It's an iterative process, so you always need to review, and the more information you get, the more informed your decision can be. So we've produced two documents. One is a field guide, and this is the guide that you would use during the training exercise. We've also developed a more detailed report. Both are available on the website, and tools and publications, as illustrated earlier. And the more detailed report will give you some of the science behind the decision-making process. Next slide, please. So just to illustrate, I mean, these are a couple of incidents that have occurred quite recently. The chlorine leak in Aqaba, where 13 people sadly lost their lives. And this involved decision-making, rapid decision-making, where beaches were evacuated several kilometres downwind of the site, and people were advised to shelter up to 10 kilometres downwind of site as well. So it shows how much of an impact these things can have. That was a 50-ton ISO tank, so quite not a small volume, but you know, quite. When you look at all those ISO tanks, there's only one of those, and it caused that sort of impact. And there's another illustration there in Spain, where an ammonia leak caused a large number of people required to be, as it says there, locked down for a while until the cloud was given the all clear. Next slide, please. And obviously with gases and evaporators, this is becoming quite important now as we start to transition into new maritime fuels. As was mentioned earlier, ammonia, methanol, LNG, these all have hazards. So what we've also done as part of the Manifest Genius project is we've developed some 2-page response sheets which give you an overview of the characteristics of each of the fuels, what their main hazards are to health, and then a step-by-step guide in how to respond quickly. And hopefully this will also complement the training guidance that we've developed and I've just talked about. Thank you very much. Again, I'll answer questions as if there are any questions afterwards. Thank you.
Thank you very much, Paul. And the last part of this presentation is just to show you what was done regarding the knowledge transfer and the training of potential end users of the tools that were developed during the 2 projects. So the main achievements was done through the upgrade of the knowledge tool, so the Manifest Mariner knowledge tool, to provide better organized information and facilitate the export of data. And also through the development of training materials that demonstrate the use of tools in 3 different formats and also in different languages. Regarding, we developed, so it was a work performed by our colleagues from CEDRE. So they developed fact sheets, PowerPoint presentation, and also a project booklet you will see just after. And then it was also done through the organization of several national and international workshops and trainings. So just to show you how the fact sheet developed by CEDRE looks like. So here is the information regarding the HNS database, but of course there is one for each tool. And all are available on the Manifest Project website on the section How to Use the Tools. And then some information regarding the workshop that were organized. So first some national that were organized in UK, Spain, France and Belgium. And also more detail regarding 3 international trainings we organize at CEDRE. So we are organizing it for the contracting parties from the Barcelona Convention, the Bonn Agreement, and also the new beneficiaries of the MARICE service. So in total, we managed to gather 62 participants from 27 countries to present the tool. So those training sessions received very positive feedback and enabled to raise awareness of HNS related challenges among key stakeholders of this sector, but also promoting the availability and operational benefits of the Manifest and Manifest Genius tool. And then the idea is now to use all the training materials that were developed by CEDRE in collaboration with all the consortium in additional training, so to keep continuing the promoting those tools and their benefits. So that will be all for us now. So thank you very much, and we are now opening the question and answer session for 50 minutes, so feel free to, just before I forget, just to let you know that the next webinar organized by CEDRE will be held on the September 21st and will deal with new fuels. So same place and same time. Thank you.
Who has a question? So if we have no question, it means that Ludovic and Paul, they were very clear, understandable. Congratulations for that. And so if there is no question, I think, Laura, perhaps we can close the webinar. Ludovic, you want to say something?
Just to say that I have already some people that ask for access to the manifest modeling app, so that's very good. I suppose you will share the slide with all the participants afterwards, so if some people did not access the link during the presentation, they can access afterward.
Yeah, yes, we will share the slide, yes.
Yes, of course. And if you have a question, of course, later on you can email us. We will be happy to discuss.
So if there is no more discussion, if Paul, do you have a last comment or something to tell?
I think I demonstrated the tools a bit like this to a meeting of the UK National Fire Chiefs Maritime Group last month, and they were very impressed with the tools on the website. I expect you had a bit of an influx of registrations on that day as well, Ludovic, because there were a lot of people downloading or registering for particularly the fire and explosion model. They were also asking whether these things could be developed into an app, which would be quite useful, I think, for when they're on scene. And
yeah.
So, but yeah, it was a very positive response from it. So that was good. But I think the tools are very useful. Yeah.
Thank you very much, Paul. Clearly, we are ready to share all the results with everybody.
Okay.
So, no more questions. Thank you very much for attending this webinar. Merci beaucoup. Thanks for your talk, Ludovic and Paul. And thank you also to all the consortium for the work that they have performed. Thank you very much for your help and for that. Laura?
No, nothing more to add. Thank you very much, and bye-bye.
Merci beaucoup. Bye.
Bye.
Good to see you. Cheers.
Bye.
Thank you. Bye.